Hello everyone! Kami ang Group 7 at ang ire-report namin ngayon is ang tunnel diode. Sa ire-report namin, merong 5 parts. Yung una doon is ang introduction to tunnel diode. Second, how tunnel diode works. Third, operation of tunnel diodes. Fourth, advantages and disadvantages. And fifth, application of tunnel diodes. Here's a quote of Leo Isaki. My English was poor, so nobody could hardly understand my presentation. Therefore, people paid more attention to my talk and the diode. So what is a tunnel diode? A tunnel diode is a heavily doped PN junction diode in which the electric current decreases as the voltage increases. Tunneling. The tunnel diode is used as a very fast switching device in computers. It's also used in high-frequency oscillators and amplifiers. This is the circuit symbol of a tunnel diode. You can see the anode and the cathode. Materials used in a tunnel diode is germanium material, gallium arsenide, gallium antimonide, and silicon. The parts of a tunnel diode is, first of all, is the anode is a positively charged electrode which attracts electrons. Cathode is a negatively charged electrode which emits electrons. N-type semiconductor emits or produces electrons, so it is referred to as the cathode. P-type semiconductor attracts electrons emitted from N-type semiconductor, so P-type semiconductor is referred to as the anode. Additional info in tunnel diode. A tunnel diode or Esaki diode is a type of semiconductor diode has effectively negative resistance due to the quantum mechanical effect called tunneling. It was invented in August 1957 by Leo Isaki. Tunnel diodes have a heavily doped positive to negative or PN junction that is about 10 nm. Our next reporter on the part 2, Raymar Rica Plaza, will discuss how tunnel diode works.
For my next report is how tunnel diode works. Working of tunnel diodes. First, if the impurity concentration of a normal PN junction is highly increased, this tunnel diode is formed. When the impurity concentration in a diode increases, the width of the depletion region decreases, extending some extra forces to the charge carriers across the junction. When this concentration is further of the carriers, they penetrate through the potential barrier instead of climbing over it. This penetration can be understood as tunneling, the name tunnel. For the step 1 is unbiased tunnel diode. You can see the diagram. When no voltage is applied to the tunnel diode, it is said to be an unbiased tunnel diode. In tunnel diode, the conduction band of the N-type material overlaps with the valence band of the P-type material because of the heavy doping. Because of this overlapping, the conduction band electrons at N side and valence band holes at P side are nearly at the same energy level. So when the temperature increases, some electrons tunnel from the conduction band of N region to the valence band of P region. In a similar way, holds tunnel from the valence band of P region up to the conduction band of N region. For the next step is step 2, small voltage applied to the tunnel diode. When a small voltage is applied to the tunnel diode, which is less than the built-in voltage of the depletion layer, no forward current flows through the junction. And, however, a small number of electrons in the conduction band of the N region will tunnel to the end of the valence band in P region. This will create a small forward bias tunnel current. Thus, the tunnel current starts flowing with a small application of voltage. Next step is when the voltage applied to the tunnel diode is slightly increased. A large number of free electrons at N side and holes at P side are generated, which is the step 3. Applied voltage is slightly because of the increase in voltage, the overlapping band and valence band is and the energy level of an N-side conduction band becomes exactly equal to the energy level of P-side valence band. As a result, maximum tunnel current flows. For the next step, step 4, applied voltage is further increased. If the applied voltage is further increased, like misalign of the conduction band and valence band phase, and since the conduction band of the N material and the valence band of the P-type material still overlap, the electrons tunnel from the conduction of N region to the valence band of P region and cause a small current flow. Thus, the tunneling current starts decreasing. For the last step is step 5. Applied voltage is largely increased. If the applied voltage is largely increased, the tunneling current drops to 0. And at this point, the conduction band and valence band no longer overlap. Tunnel diode operates in the same manner as a normal PN junction. If this applied voltage is greater than the built-in potential of the depletion layer, the regular forward current starts flowing through the tunnel diode. The portion of the curve in which the current decreases as the voltage increases is the negative resistance region of the tunnel diode. And the negative resistance region is the most important and widely characteristics of the tunnel diode. A tunneling diode or a tunnel diode operating in the negative resistance region can be used as an amplifier or an oscillator. And that's my report for my part of how the tunnel diode works. For the next reporter is the step 3 or the 3 operation of the tunnel diodes will be reported by Claire Angel 1.
Operation number 1, forward bias tunnel diode. Under the condition of forward bias, the current increases gradually as the forward voltage increases, and it continues to rise until it reaches reaches its maximum value, which is referred to as the peak current, and it is represented by the symbol IP. So the voltage measured here is referred to as the peak voltage, and it is symbolized by the symbol BP. On the graph, as you can see, this particular point is represented by the letter A. So when the voltage increases, the diode currents start to decrease until they hit their minimum value, which is called a valley point, known as valley current and denoted by IV. And it is also corresponds to valley voltage, which is indicated by letter B in the graph. So when the forward voltage is increased for a value that is more than the valley voltage denoted as VB, the current starts to increase once again, just like it would in a typical junction diode. All in all, the curve AB indicates the negative resistance region. As the resistance decreases, the voltage increases. During the operation of this, after reaching a point B, the increase in current will also increase in voltage drop across the resistor R. So, this brings the diode back into negative resistance region. So, next operation will be reported by J. Mark Santos.
Reverse bias tunnel diode. Under the reverse condition, the tunnel diode acts as a back diode or backward diode. If we consider the diode in reverse bias condition, then the diode acts as an excellent conductor as the reverse voltage increases. The diode here acts in a negative resistance region.
Hi, I am Thomas Elisis Santiago from Bet 1B. Now we are talking about the disadvantage and the advantage of a tunnel diode. First, we are talking about the advantage of the diode or tunnel diode. The tunnel diode has a long life. What do you mean by long life? Unlike the other diodes that can break easily when constantly used, the tunnel diode, you can use it for a very long time even if you use it continuously. And tunnel diode also has a high-speed operation. What do we mean by high-speed operation is the tunnel diode has a lower device that not frequently used in a circuit or electronic circuit. Due to the high-speed switching operation, they are used in a small current frequency applications. And that's the two advantage of the tunnel diode. And for the third one, it has a low noise. What do we mean by low noise? It amplifies the circuit that is directly proportional to conduct the negative resistance of the current and the operating point at a negative resistance proportion. So it don't make a lot of noise if we use the tunnel diode, and also it has a lower power consumption. Even unlike the other diodes, they use a lot of power for them to work. The tunnel diode don't use that much power. Now we are talking about the disadvantage of a tunnel diode. A tunnel diode cannot be fabricated in a large number because they are having a hard time to produce a tunnel diode. So that means we cannot use the tunnel diode more frequently even if it's useful or it has a lot of advantage. And the second disadvantage of this is being a two-terminal device, the input and output are not isolated from one another, which means that the input and output must be together, and that's the disadvantage of a tunnel diode.
Good day, I'm Ricardo Sanchez and ang i-report ko is application of tunnel diode. So first po is yung ultra high speed switch niya dahil sa tunneling mechanism, and ang switching speed niya po is nanosecond or even picosecond. Yung next niya po is yung tunnel diode is used as microwave oscillator at a frequency of about 10 GHz na dahil po yun sa extreme small capacitance, inductance, and negative resistance. So Yung po sa negative resistance, ano po siya, used when ginagamit din po siya sa relaxation of oscillator circuit. Yung next application po is used as logic memory storage. Ginagamit po siyang logic memory storage dahil po dun sa triple value featured na dun sa curve ng current. For other applications naman po, una po sa application for converting AC to DC, flippers for the waveform. And last is AM envelope detector or demodulator, diode detector. For providing an output of the envelope of the signal. So, yun lang po for aking report.